Ever wanted to predict the future? I'm not talking about crystal balls or anything like that. I'm talking about science. Well, today, we're going to unlock that exact skill. We are diving deep into the secret formula that scientists use to make predictions about, well, everything. And trust me, by the end of this, you'll be able to do it too. So, to get our heads in the right space, let's kick things off with a quote from the master detective himself, Sherlock Holmes. This idea, it's the absolute foundation for everything we're about to talk about. The key is that evidence always comes first. You see, we don't twist the facts to fit our theories. We build our theories to fit the facts. Okay, so that leads us to the big question, right? If it's not some kind of magic, how in the world do scientists look at something and actually predict what's going to happen next? Well, the answer is surprisingly simple. It all comes down to one single super powerful tool they use every single day. And that tool is the hypothesis. Now, I want you to think about it like this. What's the difference between just guessing and actually predicting? A guess, that's like peering into a fuzzy crystal ball. It's vague, you can't really test it. But a scientific prediction, oh, that's sharp, it's specific, it's totally testable, and it's built on the rock-solid foundation of a great hypothesis. All right, so let's get into our first big idea here. We're going to talk about what makes a hypothesis so much more than just a simple guess. Honestly, understanding this difference is what separates a random thought from real, actual science. So, what is it exactly? A hypothesis is just a tentative explanation. But here's the kicker. It has to be something you can test. That part right there, that's everything. I mean it. If you can't figure out a way to test it, to see if it's right or wrong, then it's not science. It's just an opinion. And science, well, it doesn't really care about opinions. Let's make this super clear with an example. A guess would be something like, I think this plant will grow big. Okay, but what does big even mean? It's so vague. Now, a hypothesis, that's different. It's specific, it's measurable, it sounds like this. If I add nitrogen fertilizer, then the plant will grow 5 centimeters taller. See that? One is just a fuzzy wish, the other is a sharp, powerful, testable idea. Okay, so we've established that a hypothesis has to be specific and testable. Got it. But how do you actually write a great one? Every single time? Well, it turns out there's a kind of secret formula, a simple but really powerful framework that scientists use. And guess what? We're about to break it all down for you. And here it is, the magic formula. It's just 3 little words. If, then, because. Seriously, that's it. This is the framework that forms the backbone of basically every scientific experiment, and it's what's going to turn your ideas into powerful predictions. Let's break it down piece by piece. The if part, that's the thing you change. In science speak, it's the independent variable. The then part, that's what you think is going to happen. It's the result you're going to measure. And then there's the because. This is the secret sauce. This is your scientific reason, the why behind your prediction. Okay, let's put it all together. Here's a classic example you've probably seen before. If I increase the temperature of the water, there's our change. Then the sugar cube will dissolve faster. That's our prediction, what we'll measure, because heat energy increases molecular movement. And boom, there's our scientific reason. See how clean and complete that is? It's perfect. All right, now that you've got the formula, let's see its power in action. Let's see how it literally transforms a fuzzy, vague idea into a legit scientific statement. This is where you go from just being a guesser to thinking like a scientist. Just look at this transformation. You start with a vague idea like, my paper airplane is the best. Okay, great, but what does that mean? Using our formula, it becomes a real hypothesis. If I add a paper clip to the nose, then it will fly 2 meters farther because the added weight stabilizes the flight path. Bam! Or how about studying? Studying makes you smarter. Okay, but watch this. If a student uses flashcards, then their test score will improve by 10% because active recall strengthens memory. See? It's specific, it's testable, and it explains why. That's science. And this really hits home what might be the most crucial part of this whole formula. Without that because, you're not really doing science. You're just gambling. You're taking a shot in the dark. That because part is what separates a wild guess from a truly educated scientific prediction. All right, you've seen the theory, you've got the formula. Now it's time to put it to work. It's your turn to step up and be the scientist. Let's make a prediction. So here's your mission, should you choose to accept it. The setup is super simple. You've got a toy car and a ramp. The big question is, does changing the height of the ramp change how far the car rolls? It's time for you to build a hypothesis. Okay, using our if, then, because formula, let's fill in these blanks together. If I raise the ramp from 10 centimeters to 20 centimeters, then the car will travel what do you think? A longer distance, right? Because gravity gives the car more what? More potential energy. The answer is a longer distance because it has more potential energy to turn into motion. See that? You just made a rock-solid scientific prediction. And really, that's the whole secret. To make sure your hypotheses are always solid, just use this simple checklist. Anytime you have an idea, just run it through these 4 questions. Did you use if, then, because, and is it testable? If you can check off every single box, congratulations! You're not guessing anymore. You are officially thinking like a scientist. So my question for you is, what are you going to test next?